Hi, this would be an overview of my thesis. We will start by first describing what we are doing, and that is specifically container forensics. And one thing that we started with was trying to figure out the challenges of container forensics. And one of the main resources that we used was NIST 8001 6. And as you can see, that while that specifically describes all of the cloud challenges, we've isolated some of the very few that were actually common to the cloud as well as the containers. And then we've made a very specific list that is unique to the containers. And as you can see over here, we have ephemeral, we have union files, we have namespace isolation. All of these are very specific um, uh, challenges within containers. And most of these particular challenges are solved through many different techniques that are already being applied within the cloud environment and usually are very much prevalent in many of the um, standards. So one thing was to actually create these environments and see for ourselves that these particular challenges actually exist or not. And for that, we actually simulated multiple different environments. As you can see over here, we would have a guide for setting up containers for a particular environment, and that is through Minikube. We have one that is through kubeadmin. This is where we're actually using a very low level approach where we are having multiple VMs and they're connecting to each other. And there will be worker nodes, and then there will be a control node. And then we have one that uses cloud services, and we're specifically using Killer Coda over here because obviously it's free and it's free for an hour. So right now we have around 40 minutes, and I've already gone and set up most of the environments. So we'll see what we're working with. So when we do cube CTL over here and get pods, we see that we already have these pods running. And if we go to the particular ports, we see this particular application is being run. And this application is already made for security people, and specifically this is for blue team, red teams, and it has a lot of different exploits for container forensics, and it's a very good way to figure out if forensics can be done on these particular environments. Now, one tool that we will be using throughout this particular presentation would be Sysdig. And as you can see, we have a native open source version of Sysdig, which is csysdig. As when we press enter for this, you would see this is collecting all sorts of different logs. And one unique thing about this isn't that it's not specifically logs, but rather system calls. So you can actually go and see all sorts of different calls that it has. So if we press view over here, we'll have all of these different views within the particular space, and we can actually select any one of these. Like I'm going to select the files one, and now these are all file calls that are present. And once we get out of this, we can specifically run a command, which is, sorry, so not this command. Okay, where is the command? Okay, so once you've done that, you can see we can actually run this command, which would potentially create an escape file. What escape file is basically, it's a file that contains a lot of different system calls, and we can use different tools like Stratoshark, which is really famous right now, and actually review all of this. Now, once we create this file, okay, such file or directory, what do you mean by that? Yeah, okay. Okay. Okay, so once we've gone through that, we can now run this command. What this will do is it's going to take 10,000 system calls and store them. Right now, we're assuming that we've done a particular attack using this particular framework and specifically gain access to the underlying Kubernetes machine. And now we'll be doing a forensics analysis. So this is specifically accumulating all of the artifacts that we will be analyzing, right? So as soon as we start that, we now will have a particular file that is called all system calls dot escape, and we will then now import this file into our particular system. But before we go on, we need to actually understand where our thesis starts. And as you can see, there are already available tools to actually gather information as well as do good logging, right? The question was, what is the major challenge for a forensics analyst? And that was actually having a lot of information to sift through. And one issue we found was that there are tools that could like reduce the amount of logs that you need to review, but there aren't any tools that could potentially cluster them in order to actually see the global as well as localized variations with them. So one of our aims was to actually build an algorithm that would first cluster all of the logs, and we would be able to see this. And this was our first part of our thesis. Okay, so basically what we did was start with actually clustering those logs. And one thing that was thought about at that time was to display these logs in a 2D space. And we figured out that first we would need an algorithm to cluster it, and then the other algorithm would be to display these particular points on the graph. And over here, we first considered using embeddings. And the reason for using embeddings is to actually get the contextualized um, part of a particular log or system call and actually be able to compare them with other logs and system calls and then actually make an analysis on that. And then once we've gathered all of those logs and we've pre-processed those logs, and then once we've created embeddings, we can display those particular logs. And this is through a particular algorithm. And as you can see over here, we have a very good way of reviewing this. So as you see, UMAP is what we're using, which is uniform manifold approximation. And as you can see, there are multiple different uh, dimension reduction algorithms, which is design and force atlas. And all of these different actually target different parts. Maybe some are focused on global structure, meaning they will be looking at overall logs and looking at the contextual explanation of the entire log. Rather, when we're looking at local structures, we're just looking at individual logs and their maybe the commonality between those, right? And so as you can see, UMAP over here lies very in the middle, so that's why we chose this. And once you go through this, you will see that our analysis did show a good form of clustering, but the issue was that it did actually reduce our overall accuracy, and we weren't able to actually detect much within the logs itself. So this idea did not actually help us in any way. So we went back to the drawing board, and one other thing that we needed to do was to actually compare word to vec, because embeddings obviously are very costly and we don't want to use it within logs. And so we did an analysis where we're actually looking at the embedding time and the clustering time and seeing what is there. And as you can see, obviously embedding time is a lot, and it's like more than 8 times the particular vector cost, Word2Vec cost. And then we're looking at the similarities, and it's a very low number in terms of overall similarities. And then we're actually doing again a comparison using a PCA, and this is just to show the clustering and basically actually getting raw data of how we're analyzing this. And at this point, we quickly understood that using 2D graphs would be a very bad idea, and we needed to evolve from that. And so the question was, what else looks like a graph and has more connections? We kind of went towards using graph databases, and obviously with Neo.js4, there was this cool aspect of basically using that to do some sort of RAG analysis where we can actually collect embeddings within the particular graph as well, and actually be able to decode analysis from there. And once we've come to that idea, we were trying to automate all of this. So we wanted that particular file that we saw that we've created over here can just be called, and once it's called, it's then able to take in the data and analyze it, and then actually upload it within the NeoGeograph. As you can see over here, we've just deleted all of our nodes. And the reason we did that is to actually show our new platform that we're working on. And this is the platform where we kind of end up. And this is actually a culmination of actually clustering the logs and actually analyzing all the logs using agents. And as you can see, there are two spaces over here. One is agent view and one is evidence view. So within agent view, we can actually drag these agents and then do a particular analysis. In the evidence view, we would have the same view as the Neo.js4 graph, and we can actually look at the graph and the evidences that it has created for us. So let's start with first setting up the agents. So we would obviously have an investigator that would be collecting all of the logs and getting all of the information. Then we would have a forensics analyst. We would have a network analyst, a forensics lead, and then would have a forensics manager. Let's just zoom out a bit, and then we'll be collecting data from the file right now. But if we were actually uploading all of this data to a database, we could just potentially give it the connection strings and it would do the exact same thing. And then we will define the output, which would be in PDF form, right? And now we just need to make the connection. So we will make the connection to the investigator. The investigator will be giving it to the network to analyze it. And then the network will be giving it to the forensics team lead. And then the forensics team lead would be giving it to the forensics manager. And then once the manager analyzes data and actually sees all of the information, it can then create a PDF file, right? And now we can actually choose the particular file. So for example, right now we're going to choose evidence.txt. And once we press open, this file gets uploaded. And now one thing that we can do is we can actually chat with different agents. So has been processed, we can write what is present in the file, and then we have to wait for a response. And okay, so basically over here, it will give you the exact same information. And over here, you can also ask, how will you perform the evidence, perform the analysis of the evidences? And now it's going to give you a more specific response of what it as an investigator can specifically do to perform the evidence. And these are the particular things that it will be doing. It'll be checking for analyzing access logs, all of this information. It has access to tools, so it can specifically ask the user proxy for a particular data and then do further analysis on that. So this is the whole explanation. Okay, once we've done that, now the point of it is to actually do the whole analysis itself and then upload it to evidence view, right? So right now there aren't any data over there, and just to actually make sure, what we'll do is to actually go to the place and delete the report so that there are no reports over here. And now once we generate, now it's going to start generating. And as you can see over here, it's taken in data, it's actually analyzing all of the data, and then it's asking the forensics manager to actually analyze all of this data. And once this is done, it's gonna call some tools. And so one tool that it's gonna call is the PDF tool to actually save the PDF. And you can see over here the agent themselves call this tool. And the other tool that they will call is the Neo.js4 element that will be calling another tool that would then be uploading all of this data. And as you can see over here, all cipher statements have been successfully uploaded. So getting the file, which is the report, and we can now see what the report was. And as you can see over here, it describes all of the events that took place and what it expects. And these are the analysis of multiple different agents. So you can see over here the investigator findings, and we have the network analyst, we have a forensics lead review, and then we have the conclusion that actually describes what it is. Now we can actually go to the agent is view again view. And as you can see over here, we get this particular evidence. And over here, when we press on timestamps, we can see when this particular event occurred, the evidence, which was the particular auth log. Then we have the user, which is the root. Then we have evidences, which is the particular text, the particular IPs, and other stuff, right? We can also see within the Node.js4, obviously a bit better graph. It's the same information, just put in a better way. We can actually improve our algorithm to actually get all of this information. And you can see the information that the agent sent, there is a clear indicator of potential brute force attack, and we can see from which IPs, at what time, who was affected. All of this information is gathered by the agent and can be able to provide you a fast analysis of the overall workflow.